In this video you will see what is a horizontal asymptote. Let's see it on axis. This is x-axis, y-axis. Now, if there is a horizontal asymptote of a function, then either it will be the x-axis or it will be parallel to the x-axis. As it is a horizontal asymptote, that means it is a horizontal line. Now let's say this is the curve of some function f of x. Now here we see the distance between this line and this curve is getting smaller and smaller as the curve grows in this direction. That is, the distance between this line and the curve is getting smaller and smaller as x is getting arbitrarily large in magnitude, that means from any side. So, which means if there is a horizontal asymptote of some function, then this distance gets smaller and smaller when x is getting bigger and bigger. So to find the horizontal asymptote of some function, we have to check the behavior of the function when x is approaching to positive infinity or negative infinity. So let's do it in some example. Let's say this is a function f of x which is given by 2x plus 1 over 4x square minus 9. Now, to find the horizontal asymptote of this function, we have to check the behavior of this function when x is approaching to positive infinity or negative infinity. That is the end behavior of this function. So that means I have to find the limit of this function when x is approaching to infinity. So 2x plus 1 over 4x square minus 9. Now, here, as the degree of denominator is more than the degree of numerator and x is approaching to infinity, that means the value of denominator is arbitrarily large as compared to the value of the numerator. And when the denominator is arbitrarily large, the whole fraction approaches to 0. So let's do it in some different way which we usually follow when we have to find a horizontal asymptote. So in that method, what we have to do, first we have to find the degree of the denominator, that means the maximum power of x in denominator, and in this case it's 2. So the next step we have to do is we have to divide the numerator and the denominator by x raised to power 2. So 2x plus 1 over x square, and in denominator 4x square minus 9 over x square. So I divided the numerator and denominator by x square. So I can write it as 2x over x square plus 1 over x square, and in denominator 4x square over x square minus 9 over x square. So I can cancel out the like terms. This gets cancelled, and here x raised to power 1 is cancelled by 1x. So there are two x's, one x is cancelled. So I get limit x approaches to infinity, 2 divided by x plus 1 by x square, and in denominator 4 minus 9 over x square. So now when x is approaching to infinity, this term and this term, these three terms approach to 0 as the denominator is arbitrarily large. So what do I get? 0 plus 0 over 4 minus 0, which is equal to 0 over 4, which is equal to 0. And the same way, if I take the limit x approaches to negative infinity, x is approaching to negative infinity. The same way, again, these three terms approach to 0, so we get the same value. When x is approaching to positive infinity or negative infinity, the function is approaching to 0. So what does that mean? Y equals to 0 is the horizontal asymptote of this function. Now I'll make the graph of this function and we'll see how does this horizontal asymptote look like on the graph. So this is x-axis, y-axis. Now this function is undefined at negative 3 by 2 and positive 3 by 2. This function is not defined at these 2 points as the denominator is 0 at these 2 points. So at negative 3 by 2 and at positive 3 by 2. The function is undefined. So these two are the vertical asymptotes of this function. I've done the last video which shows how to find the vertical asymptotes, but here we have to find the graph of this function. For that, you can pick some random values of x and find the corresponding values of f of x and then plot those values. Then by joining all those values, you can find the graph of this function. Either you can use a graphic calculator to find the graph of this function. So the graph of this function looks like this. Now here we see as x is approaching to positive infinity and negative infinity, this distance from both sides is getting smaller and smaller. That means this line y equals to 0 is the horizontal asymptote